Hello everyone. This is the first lecture on atomic and molecular physics for GATE. Okay, so atomic and molecular physics we will study in this lecture series. Okay, for GATE. Okay, so I won't start with the basic. I will start directly with molecular physics. Okay, because that's where questions come from. So instead of like going into detailed study, we'll just go through things that actually come in exam, isn't it? Okay. So, mm, so we'll directly go to the what molecular physics. Okay. So there are heteronuclear molecules, heteronuclear, homonuclear, and polynuclear. Okay. Heteronuclear, homonuclear, and polynuclear. What is heteronuclear? Heteronuclear is HCl, HBr, okay, CO, etc. Homonuclear are H2, N2, O2, etc. And your polynuclear are CH4, SF6, and P2O5, etc. Heteronuclear molecules are MW active, macrowave active. These are microwave inactive, homonuclear, and these are microwave inactive. So question may come, which of the following is which of the following molecules is microwave active, isn't it? Option A CH4, HCl, SF6, N2. So answer will be what? HCl, because HCl is your microwave active. Okay. So but this one is basically, this is a two one mark question in GATE. So this is basically memorization. There's nothing, no concept here, nothing to. You can one way remember all the halides. They come in the heteronuclear, homonuclear, same molecule H H, that is H2, N N N2, O O O2. So homonuclear. This is different. Hetero, different. HCl, different. Okay. Polynuclear, many, C along with 4H, that is poly. S along with 6F. Okay. 6F, poly. This is hetero, means different, two but different. This is same H H, so homo. Okay. Hetero are microwave active, homo are microwave inactive, poly are microwave inactive. All right. And next is what? Next is a pure rotational spectrum. Pure rotational, pure rotational spectrum. All right. Pure rotational spectrum. Okay. It is shown by what? Shown by heteronuclear molecule. Shown by heteronuclear molecules. All right. So, and they have, it is shown by what? They have permanent dipole moment. They have permanent dipole moment. All right. And observed in what? Observed in absorption spectrum only. These are one mark questions. Can come in gate. Absorption. It won't come in NATE like direct, but gate you can trust. Spectrum only. Okay. So now, next is diatomic molecule as a rigid rotator. As a rigid rotator. So diatomic molecule, there are two molecules M1. This is M2. This is M1. Their distance is R. Okay. So here bond length R will be fixed. Bond length R will be what? Fixed, isn't it? Bond length R will be fixed. So reduced mass will be what? Reduced mass mu is equal to M1 M2 by M1 plus M2 always. This is your reduced mass, isn't it? And your moment of inertia will be moment of inertia. Moment of inertia is what? I. I is mu r square. Mu is your what? Reduced mass. Okay. What is the energy of the rigid rotator? Energy of the rigid rotator is what? E is equal to, no, don't write like this. E is equal to h cut square by 2I j whole into j plus 1. Okay. J whole into j plus 1. Alright. So energy in terms of wave number will be what? Energy in terms of wave number. Wave number will be written like this. Bj into j plus 1, or you can write it like this. E is equal to Ej is equal to Bj whole into j plus 1. This unit will be centimeter inverse. Okay. Wave number unit. Wave number unit, that is centimeter inverse. Alright. And what is B? What is a B? B is simply h cut square by 8 8 pi square IC, that is of B, where B is called what? Rotational constant. B is a what? Rotational constant. B is equal to h cut square by 8 pi square IC. B is what? Rotational constant. So selection rule is what? Here selection rule is del J is equal to plus or minus 1 in pure rotational, diatomic molecule as rigid rotator. Okay, so your E values will be what? Ej values will be 0, 2b, 4b, sorry, 6b, 12b, like that. How? Because your this will be what? Bjj plus 1. If it is 0, then it's 0. If it is 1, then 1 into 2, that is 2b. If it is 2, then 2 into 3, that is 6b. Okay, it will go on like this. Alright. So if I draw this spectra, so if I draw the spectra, it will be like what? See, this is your J is equal to 1, like rotational levels. This is where 0, 2b, 6b, right? 12b. The difference should be different. It's just I have done it a little bit. So like J is equal to 1, J is equal to 2, like this. Okay. Yeah. This is your what? Rotational line. Alright? Yeah. And these are what? Rotational levels. And the difference should be like 2v, 4b. Okay. So you can see this is 2b, 2b, 2b. So you can say rotational lines are actually equidistant. but rotational levels are not equidistant. Equidistant. Okay. All right. Yeah. Okay. So next is like, so your so you can say J is equal to what? I omega. Right. So J is also h cut J whole into J plus one, isn't it? So omega is equal to what? If you compare, omega will be h cut by I, h cut by I, J whole into J plus one. You just have to equate it. I omega is equal to this one. So omega is h cut by I, J whole to J plus one. Alright. So rotational frequency will be what? H cut by 4 pi square I, J whole to J plus one. Okay. This is your rotational frequency. These ones you don't need to remember. You can do it on your own in exam hall. You can derive them on your own. Okay, next one is important. Next one is, for example, asked most populated level. For example, it is asked most populated level. So for that, see ratio of number of atoms in the jth level and j plus one level. Okay, to the ground level. To the ground level. That is nj by n naught is equal to 2j plus 1 daily by kbt, sorry, daily by kbt. Okay, for most populated level, what we have to do? Most populated level, dnj by dj is equal to 0. Okay, so take the derivative, you will find nj is equal to what? N naught 2j plus 1 e to the power minus bj j plus 1. Okay, rc by kbt. Okay, N naught 2j plus 1 e to the power minus bj j plus 1 rc by kbt. Sorry, h gets okay. Next is diatomic molecule as diatomic molecule as non-rigid rotator. Previous one was rigid rotator. This one was non-rigid rotator, right? So what will be this one? Ej is equal to, so this term will be there, bjj plus 1. Along with it, there will be another term, bj square j plus 1. Okay, this is due to what? This is due to centrifugal force. This is due to centrifugal force. Okay. Yeah. Here, rotational lines are not equidistant. You can put the values, you can see, are not equidistant. Okay. Yeah. Okay. So next is what? Next is an isotopic effect. Isotopic effect in rotational spectrum. Okay. So what will happen? V inverse proportional to 1 by mu. Right? Okay, let's go to questions. First question, question number 1. Question number one of molecular physics. The first is absorption spectrum of 12C16O is at 3.842 centimeter inverse, and first, while that of what? That of 13C16O is at ratio of the moment of inertia. So we know moment of inertia like B is inverse proportional to I, like we just did it. Like how? B is proportional to mu, right? So in that way, B should always also be inverse proportional to I because mu R square is I, isn't it? If I multiply this will be I. So B is also inverse proportional to I. So I can write I of 12C divided by I log 13C 16 is equal to B of 13C 16O divided by B of 12C 16O. So B of 13C 16O is how much? 3.673 divided by B of 12C is how much? 3.842. Okay, there is one thing here, the ratio of the moments of inertia. So the answer is coming in 1 point in the options. So I think you have to take the ratio the other way. Okay, like I13 by I12. I think this is a mistaken question, but anyway. So you should take it as 8.4, 3.842 divided by 3.673. So the answer will come as, if you divide, it will come 1.046. Okay. Even if someone does it wrong, you will get the right answer. So this is the thing about this. It should be I1 by I2, but this is done wrong way. The options are wrong. Okay. Okay, next question. Consider the hydrogen deuterium molecule. Question number two. Hydrogen deuterium molecule. Okay. HD. If the mean distance between the atoms is what is this? 0.08 nanometer, mass of hydrogen atom is this, then the energy difference daily between two lowest rotational states. Okay. So HD. One is hydrogen, another is what? Deuterium. So what is the reduced mass? 1 into 2 divided by 1 plus 2 AMU. Well, right. That is what? 2 by 3 AMU. AMU means 2 by 3 into 1.6 into 10 to the power minus 27 kg. Alright. So this is a mean distance between hydrogen and with the atoms is this. Mean distance R is equal to 0.08 nanometer. That means 0.08 10 to the power minus 9 meter, 8 into 10 to the power minus 11 meter. Okay. So the energy difference daily between the two lowest levels. Two lowest levels. Okay. Two lowest levels. So here that means what? What we have to do? So Delhi is equal to what? Like B like what? J1 to J plus 1. So Delhi is equal to B for okay. For J is equal to 0. Lowest energy level J is equal to 0. E is equal to 0. J is equal to 1. B is E is how much? 2B. Right? 2B. So 2B means what? 2 into h cut square by 2I. This is the formula for this. So this is your what? H cut square by I. Hmm? So h cut square by I, that is 1.04 and 10 to the minus 34 whole square by I is what? Mu R square. Mu is, you have calculated mu. You have calculated mu. Mu is what? We calculated mu as 2 by 3 into 1.6 and 10 to the minus 27. R is what? 8 into 10 to the power minus 11, isn't it? So this is your what? This is your energy. The answer will be around. Okay, so this is it. This one you'll be getting in Joule, I think. So you have to convert it into electron volt. Alright? Yeah. So next is what? Next is your vibrational spectrum. Next is the vibrational spectra. Okay. Vibrational spectrum. It arises from the vibrational motion of a molecule. Okay. It's the phenomenon of IR region of electromagnetic wave. IR region. Alright. So see what happens here is your so 0 to 1 here change of 0 to 1 state will be fundamental band. Okay. Fundamental band. 0 to 2 will be what? It will be called first, and this is the first fundamental band. This will be the first overtone. 0 to 3 is second overtone. 1 to 2 is what called second fundamental band. Like this it will go on. Okay. 2 to 3, third fundamental band. It will go on like this. Alright. So what is the this is what the value of nu. We write it as nu or V. Sorry, V. Okay. So what is the formula for it? The vibration energy will be what? Vibrational energy in terms of wave number. Okay. I write it. Uh, EV V plus half squared omega, that is V plus half squared new oscillation. Right? Where new oscillation is what? 1 by 2 pi root over of k by mu. Right? This is called what? Vibrational frequency. This is called vibrational frequency. Okay? So what is the selection rule here? Selection rule in vibration. Selection rule. Selection rule is del V is equal to plus or minus del nu is equal to plus or minus. So del V here actually del V. Okay, you will know slowly. Right. So E is equal to what? EV is equal to E divided by HC. That will be V plus half. Okay. New oscillation by C. That will be write as V plus half omega E. Okay. This is your omega E. Where omega E is what? New oscillation by C. Alright. Yeah. So if we see this, if we see it, now we'll write diatomic molecule as an harmonic oscillator. An harmonic oscillator. Alright. So the formula will be EV is equal to V plus half squared omega minus this half square. Sorry. Omega E V plus half square omega E chi E. This is your chi E is equal an harmonicity constant. Harmonicity constant. Okay. And omega E chi E is called an harmonicity term. Alright. So can do one thing. You can put the values of, like for example, 0 to 1. This is called a what? Fundamental band. Fundamental band. So first, E0 is how much? Omega E by 2 minus 1 by 4. 1 by 4 omega E by 4. E1 will be what? 3 by 2 omega E minus 9 by 4 omega E chi. So you can have the del E is equal to 1. You can subtract it. It will be omega E minus 2 omega E chi. This is a what? Fundamental band. First fundamental band. Next. Next is what? Next is what? First overtone. First overtone is what? First overtone is 0 to 2. Okay. V0 to 2. V0 to 2. So V U0 E0 to we know that is this. It's 1 by 4 omega E chi. E2 is equal to how much it is? 5 by 2 omega E minus 25 by 4 omega E chi if you put the values. So del E 0 to 2 will be this will be what? 2 omega E minus 6 omega E chi. Right? This is a what again? This is your first overtone. Okay. So go on like this. Right? Yeah. Now first, okay, second fundamental band will be V1 to V2. This is called what? Hot band. HOT all capital hot band. So here V1 is how much? 3 by 2 omega E minus 9 by 4 omega E chi E. EV is equal to 2 is how much? Um, 5 by 2 omega E minus 25 by 4 omega E chi E. So del E 1 to 2 will be how much? Omega E minus 4 omega E chi. This is called what? Hot band. Alright. Yeah. So what is isotope effect in vibrational band? Let's see. Isotope effect in vibrational band. Isotope effect in vibrational band. So V new oscillation would be inversely proportional to the root over of mu. Okay. Okay. So there are some branches of vibrational rotational spectrum. Okay. What are the branches? Branches are P branch. In P branch, what happens? Del J is equal to minus 1. Q branch, del J is 0. R, del J is 1. Okay. Yeah. Next is the question here. Yeah, this question. In the leading harmonic correction to the energy of the nth, question number 3. Nth vibrational level of a diatom molecule is minus chi n plus half whole square omega with chi is equal to 0.001. Total number of energy levels possible. Okay. So we know energy is what? N plus half squared omega minus omega e chi e n plus what? Whole square. So if we take d by dn is equal to 0 because we need what? Maximum. Okay. So if I do the derivative to be h squared omega minus 2 n plus half may chi h squared will also be there is equal to 0, isn't it? So that will give me what? H squared omega minus 2 chi h squared omega n plus half 0. That means h squared omega is cancelled. 1 is equal to 2 chi n plus half. 1 is equal to 2 into chi value is given as 0.001 and plus half. This is how much? 0.5 divided by 0.001 is equal to n plus half. That is equal to 5,000. Okay. Is equal to n plus half. So n is equal to 5,000 minus 0.5. That is almost 5,000. So 5,000 energy levels are there. Alright. So this is the answer. This is 5,500. 500, sorry. Really bad. My bad. 500. Okay. So this will be the type of questions like that will come from this chapter. They will ask you fundamental band, first overtone, okay, second overtone, those things. Right. So this will be it from this video. We will discuss more questions in the upcoming lessons. Thank you.